Hello everyone. Let's begin with a situation you've probably seen. Two people carry identical sacks of cement to the third floor. One reaches in 30 seconds, the other in 1 minute. They both do the same amount of work, right? But one does it faster. That difference is what we call power in physics. It tells us how quickly work is being done. So let's explore this powerful idea, pun intended, and understand how power connects work with time. Now let's look at the definition of power in physics. Power is the rate at which work is done. If W is the work done and T is the time taken, then power equals work divided by time. In symbols, we write P equals W divided by T, where P is power, W is work in joules, and T is time in seconds. So 1 watt equals 1 joule divided by 1 second. That's the SI unit of power, the watt written as capital W. If someone can do more work in less time, they have more power. Let's take a real-life example. Suppose Coolie A takes 1 minute to lift a bag to the top of a bus. Coolie B takes 2 minutes to lift the same bag to the same height. Now both of them do the same amount of work, but Coolie A does it in half the time. That means power of Coolie A equals 2 multiplied by power of Coolie B. So even though the work is the same, Coolie A is twice as powerful because he's quicker. That's how we use power to compare rate of doing work. Let's now derive another important formula for power, the one that includes force and velocity. If a constant force F acts on a body and moves it through a distance s in time t, then the work done is W equals F multiplied by s. Now substitute this into the main formula for power. P equals W divided by T. Substituting W as F multiplied by S, we get P equals open bracket F multiplied by S, close bracket, divided by T. Now, since distance s divided by time t equals v, which is average velocity, we substitute s divided by t with v and get P equals F multiplied by v. So this gives us an alternate formula. Power equals force multiplied by velocity. It's very useful when both force and velocity are given. Let's solve a numerical example. A force of 10 newtons moves an object through 20 meters in 4 seconds. Let's calculate the power. Step 1. Work done, W, equals force multiplied by distance. So W equals 10 newtons multiplied by 20 meters equals 200 joules. Step 2. Power equals work divided by time. So P equals 200 joules divided by 4 seconds equals 50 watts. Final answer, the power used is 50 watts. This means that energy is being transferred at a rate of 50 joules every second. Let's quickly revise what we've learned today. Power is the rate of doing work. Formula 1. P equals W divided by T, where P is power, W is work in joules, and T is time in seconds. SI unit of power is watt, where 1 watt equals 1 joule divided by 1 second. Power increases when the same work is done in less time. Alternate formula, P equals F multiplied by Z, where F is force and V is average velocity. Now, whenever you see a light bulb marked as 60 watts, you'll know it means it uses 60 joules of energy every second. That's the magic of understanding power. It connects motion, energy, and time.